Welcome to this explainer. Today, we are looking at something truly fascinating: the massive, literally invisible engineering frameworks that power the digital ecosystems we rely on every single day. If you've ever wondered how the world's biggest apps manage to do, well, everything at once, without just instantly crashing, you're in the right place. Let's get into it.
Okay, let's dive into this. Our roadmap today covers the rise of SuperApps, decoding microservices, and the Mini App ecosystem. Then we'll weigh the ultimate trade-offs, uncover a seriously shocking security vulnerability, and finally, explore the hybrid future.
Section 1. The rise of SuperApps, the scale of digital ecosystems. So, we're talking about massive platforms here. Think WeChat, Alipay, Gojek, that consolidate everything into one place, which brings up a completely mind-boggling engineering problem. Now you might be wondering, how does a single app support 1.3 billion users without crashing? Taking Alipay as an example, this level of concurrency is just unprecedented. Managing thousands of integrated services for over 1 billion people is a monumental task. It literally requires architectural perfection.
And the stakes for getting that architecture right, they have never been higher. To put this into perspective, the global market for SuperApps is projected to blast past a massive $400 billion by 2030. With mobile internet access expanding and this huge demand for unified digital experiences, the technical foundation of these platforms is absolutely going to dictate the future of the digital economy.
Moving right along to Section 2. Decoding microservices, the back-end powerhouse.
At its core, the microservices architecture decomposes these massive, monolithic applications into loosely coupled, independently deployable back-end services. It's kind of like a highly coordinated team of independent specialists working in a massive factory. By using containerization tools like Docker and orchestration platforms like Kubernetes, each service operates in total isolation. So if the payment service needs an update, no problem. You don't have to take down the entire messaging service just to do it.
And this brilliantly illustrates the tangible benefits of this approach. By allowing specific services to scale dynamically based on traffic, organizations have reported up to an 80% improvement in resource utilization. Plus, continuous integration pipelines can reduce downtime to under 1 minute. For mission-critical systems like digital banking, this kind of resilience is absolutely vital.
All right, Section 3. The Mini App Ecosystem, Front-End Modularity. Now, mini apps operate on a totally different philosophy. These are lightweight, modular applications built with standard web technologies, like JavaScript and HTML5, that reside entirely within a host SuperApp. Think of it like a giant sports stadium. The SuperApp is the stadium itself, right? It provides the security, the ticketing, the whole infrastructure. The mini apps are basically the franchise concession stands inside. They get to leverage the stadium's built-in authentication and payment systems without ever needing to touch the stadium's core blueprint.
This setup is a real game changer. It enables incredibly rapid third-party development and ensures really consistent user interfaces across the whole platform. But here's the catch. While mini apps offer this amazing front-end agility, they don't scale themselves. They rely completely on the centralized host SuperApp's massive cloud infrastructure and distributed databases to actually handle those millions of users.
Let's move to Section 4 and see how this builds into our next topic, the ultimate trade-offs: microservices versus mini apps.
When we compare these architectures head-to-head, we see a massive operational divergence in scalability. With microservices, scaling is perfectly tailored at the service level. It's totally independent, usually managed by orchestration tools like Docker Swarm or Kubernetes. Mini apps, on the flip side, scale at the platform level. They share centralized cloud resources, which means their scalability is entirely dependent on the host SuperApp's elastic cloud.
And when it comes to modularity, the contrast is super stark. Microservices give you deep infrastructure modularity. Developers have full, granular control over back-end logic, databases, you name it. Mini apps, however, provide what the source calls superficial front-end encapsulation. Basically, they are heavily constrained by the host platform's runtime policies and software development kits. They just have very limited architectural autonomy.
Okay, tone shift for Section 5, the hidden privacy threat, a silent vulnerability.
So, while microservices use standard, well-documented security measures like role-based access control and encrypted comms, the mini app model harbors a massive, largely unregulated blind spot. This vulnerability is exposed through something called a theft attack, target history exploitation for feature tracking. Because mini apps live inside a central host, the SuperApp is passively collecting vast amounts of interaction data. We're talking navigation paths, the specific buttons you tap, the functions you call across different mini apps. This data is silently logged, and as it turns out, it can be heavily exploited.
So the crucial point is this terrifying statistic, 95% accuracy. By analyzing these seemingly harmless, passive interaction logs, a theft attack can use machine learning to infer highly sensitive personal attributes about a user. It's crazy. We're talking about accurately predicting a user's age, gender, financial status, and even their political views, literally just based on how they tap around inside these mini apps.
And what makes this even more alarming is the industry's response, or actually the lack of one. According to the research, of 31 SuperApp vendors analyzed, only one explicitly acknowledged these data privacy risks. That single vendor? WeChat. For the vast majority of SuperApps out there, users are not informed about this data collection, nor are they given opt-out mechanisms. It just leaves a massive, unregulated attack surface wide open.
Finally, Section 6. Building the hybrid future, the best of both worlds.
To resolve these architectural conflicts, the future really isn't about choosing strictly between microservices or mini apps. It's about intelligently combining them. Now, what's really interesting about this approach is that in a hybrid architecture, microservices handle all the heavy lifting and mission-critical back-end logic. They make sure authentication, data storage, and payments are secure and scalable. Meanwhile, mini apps drive that rapid deployment, modular front-end interface. And sitting right in the middle are the API gateways, orchestrating a secure flow of data between the back-end and the front-end. WeChat, again, is a prime example of successfully pulling off this exact balance.
But of course, combining these systems means we have to address those privacy blind spots we just talked about. Securing this hybrid ecosystem requires strong technical defenses, like advanced data anonymization and trusted execution environments, combined with really strict policy-level safeguards. Transparent user consent mechanisms and absolute compliance with privacy laws like the GDPR and China's PIPIL, they are no longer optional. They're mandatory to prevent inference attacks from exploiting our data.
Which leaves us with a really critical thought to ponder. Will future privacy legislation evolve fast enough to protect our data within these massive hybrid ecosystems? As these super apps just continue to expand, finding that perfect balance between seamless, highly scalable tech and fundamental personal privacy, well, that's going to be the defining engineering challenge of the next decade. Thank you so much for joining me for this explainer, and I'll catch you in the next one.